Today we're going to be talking about integration by substitution. I don't know why. Yes. Okay. Sorry, it looked like my audio wasn't working and I was confused. Okay, so let's look at this integration here. I don't know how I would integrate that because I don't want to multiply this out 50 times. That'd be insane. But if you notice right here, this 2x is the derivative of x squared plus 1. So if I let u equal x squared plus 1, and I take the derivative of that with respect to x, we get 2x. And not the best algebra, but if you multiply both sides by dx, I now have the integral of u to the 50th power, and then this whole thing here is my du. So now I can take the integral of this, add 1 to my exponent, 1 over my new exponent, don't forget your plus c, and then you can substitute in. Okay, so what integration by substitution is it's undoing the chain rule. Okay, if you look at this is kind of a version of the chain rule. If I let u equal the inside of some function, okay, so I let u equal g of x, then I find du to be g prime of x times dx. So now this piece is my du, and I go and I'm taking the integral of f of ru times by du. Well, that's big F in our notation plus c, and then we plug in g of x. Now, if I were to take the derivative of this, so if I were to take the derivative with respect to x of f, big F of g of x plus c plus, I don't know why I put d. I was thinking about the dx plus c. I have the derivative of big F is little f of g of x times by the derivative of the inside. Derivative of c is 0, so that's what I get there. So that's kind of why u substitution works out. Okay, so some steps for u substitution is pick a substitution, and I stole these from our book. I actually really like, and this is typically going to be an inner part or piece inside a composition function. Okay, and then you find du dx. Rewrite it all in terms of the variable u. If you end up with not being able to write it all in terms of the variable u, you're going to have to do some manipulations. Integrate with respect to u, and then you substitute back in. And then remember, you can always check your answer by taking the derivative. Okay, and again, I stole this from the book down here, and I really like that it shows an inside function, derivative of the outside function, and then an outside function. Okay, I really like that you're picking your u to be this inside function of a composition. My students have often struggled with that when they're first learning this, is having trouble picking their u. So I'm really trying to highlight this with you. Okay, so I stole these from our old textbook, and a lot of times I started with telling you what the u is. Okay, so my u is 4x squared plus 5. So I find du to be 8x dx. Okay, so I have the 3. I'm going to pull the 3 out in front. this was my u. Okay, this here, I need 8x dx. So I have an x dx. I need to get an 8 in there. So I need to multiply by 8 on the inside and 1/8 on the outside, because that's like multiplying by 1. So then I have 3/8. This 8 and this x dx becomes my du. Manipulating that a little bit. Maybe you guys are better at it than I am. I always have to write this with a negative exponent because I add 1 to my exponent, 1 over my new exponent. Don't forget your plus c. Okay. And then you want to substitute back in and do some simplification. So I have 3/4. U was 4x squared plus 5 to the 1/2 power plus c. Okay, this one is kind of a fun substitution. Okay, so we're making the indicated substitution. U equals x over 5. So du is going to be 1/5 dx. Now it's not completely clear why they're making us do this x equals 5 or u equals x over 5. But I know if I multiply both sides by 5, 5u is going to equal x. So let's watch this manipulation. First of all, I'm going to factor out the 2. I need a 1/5 dx. So I'm going to multiply by 1/5 and a 5. So I should have another 5 out here. So this becomes my du. On the bottom, I have 5u squared plus 25 I can factor out a 25. I have 10 over 25 integral du of u squared plus 1. This is going to reduce, so if I reduce everything, I get 2/5. This becomes the inverse tangent of my u plus c, and my u was x over 5. And again, I can always take the derivative of this, and hopefully with some simplification, I'm going to get this back. But that was kind of a fun substitution. Okay, evaluating this integral. So evaluating this integral, I really like this one because you have to pick out your u. And a lot of the times, I would say some of the time, with trig functions, it's usually what's in the angle. So it's usually this piece in here. So du is equal to 5 dx. So we need a 5 inside, a 1/5 outside. Just so you know, some teachers, if you have teachers in college, some teachers will solve for the dx and substitute in. And you can do that too if you want. I don't care. Okay. And then from here, what function's derivative is cosecant cotangent? That's negative cosecant of u plus c, my u was 5x. Next example. Again, picking that u. And this is the hardest thing to sometimes for students to do is what do I do to pick my u? Okay, so usually if you have a function with another function, okay, so pick that u to be the square root of y. So du 1/2 y to the negative 1/2 dy. Well, I do have that. I have that right here. I just need to add in a multiply by a 1/2 outside, multiply by a 1/2 inside, a 2 outside. So we get 2 integral of e to the u du, and e to the u, I always love that. It's e to the u plus c. My u was the square root of y. So let me show you that if I took the derivative. I took the derivative of this, okay? 2 times by e to that times by the derivative of the exponent. Derivative of c is 0. I do get what I have here. Okay, the 2, the 1/2 cancel. I get e to the root y over the square root of y. Sometimes you really have to do a whole lot of fun manipulations. So here for this example, you actually have to split this up into sine squared x times by the sine of x. Don't forget about your dx. Now sine squared is 1 minus cosine squared. Ooh, I don't like how I wrote that because I forgot my x. Now this is technically a composition. This is technically 1 minus cosine squared. So for this, pick your u to be the cosine of x, because when I find my derivative of cosine, my derivative of cosine is the sine of x, and that's hanging out right here. So all I need to multiply by is a negative 1 inside and outside. So I now have the integral of 1 minus u squared du, because this whole thing here is my du. So I have negative of u minus 1/3 u to the third plus c. So that is negative cosine x minus, but I'm bringing in my negative 1/3 cosine cubed x plus c. All of these were indefinite integrals, ones where I didn't have integral limits. I wasn't finding the area under the curve. This one, I now have integral limits. And there's really two methods. And yes, you need to know both of them. I don't care which way you use, but you need to be familiar with both of them. Okay, so notice, I'm going to rewrite it. Notice that here, if I look at this, I have the derivative of that sitting right there. So I let my u be 1 plus x to the third. Du is 3x squared dx. So this turns into the integral of u to the fifth du. Now notice how I didn't write the numbers because these are in terms of x. So I don't write the numbers, okay? I go ahead and assume that it's indefinite. And what I do from here is I then take the antiderivative of that u to the sixth power, and my u was 1 plus x to the third. Now since everything is back in terms of x's, I can add in the 2 and the 0. Okay, and simplifying this, you get 1/6 of a 9 to the sixth minus a plug in 0, I get 1 to the sixth. I was looking at my notes and I have something different in my notes because I screwed something up. Okay, and with this large of number, I wouldn't expect you guys to do that. I did it in my calculator and I got 531,440/6. Okay, I wouldn't expect you to do 9 to the 6th without your calculator. So that's method 1, where I didn't change these integral limits. I said, okay, I'm going to look at this like it's a indefinite integral, and then once I've substituted back my x, I can now say 2 and 0. There's another method where, okay, same work over here, but I can change this to u to the fifth du, but I can write these integral limits in terms of u. So if I plug in x here, if I plug in 2 for x, I get 9. If I plug in 0, I get 1. So now I take my antiderivative, and I don't substitute back in this at 1 plus x to the third. Okay? I just leave it as is. So I now have 1/6, 9 to the sixth minus 1 to the sixth. Okay? And that's either way is correct, right? And you're able to pick both methods. A lot of times on the AP, they will say which one of the following integrals is equal to this, and they'll have everything in terms of u. And that's a common multiple choice question. Okay, thanks for watching my video on integration by substitution.